Blender Studio Live Noding. In this episode, I want to share with you the breakdown of this node tree setup using SVerchok that's used to control the fluid emissions. Okay, so this is flip fluid in Blender, and I think I've shown you something similar in the past, but I'm just gonna do it again using SVerchok. And we basically have 6 different icosphere here, and those icospheres are the inflow for the fluid, and the fluid can be controlled by enabling or disabling this emission toggle. Okay, currently you can see it's being keyframe already. The animation is already baked, and the on and off of the fluid emission is being controlled using SVerchok. So this is SVerchok basically loading all the icospheres, so it's becoming like a drivers for the flip fluid inflow is enabled. Okay, so it's a simple system and it simply just works. And we have this fluid domains, and we also have this plane that's becoming the outflow, so when the fluid touches this floor, it's gonna disappear. So yeah, it's pretty simple system, and currently you can also see this visualization of the data, which is shown here. So basically I have a frame numbers that's been divided here using integer division, so the step is kind of slower, and I pass it into the number range and sine wave, and then map the sine wave so it goes between 0 and 1. So this boolean number is now controlling the inflow of the fluid emitter. I have 2 examples here. This one is using random number for each one of the emitter between 0 and 1, and it's gonna move every 10 frames. So this is the result. So the result is gonna be really different if I plug it here. So instead of this kind of pattern, you can see this pattern now. It's gonna be completely different. Let me actually do the baking once. I need to do the baking manually, because this is something that should have been done using Python, because SVerchok doesn't really bake numbers unless I'm forgetting something. But anyway, I just reset the fluid and I will bake. So this is the new pattern. Is more random, and we can visualize the pattern by piping this boolean into the Z. Okay, so this is the new pattern. So whenever we have like 0 or 1, we can see it over here. So if it's 0, the emission stop emitting the fluid, and then we have like a gap. So you can use this system to actually draw like a message, kind of like a hidden message, a little bit like a telegraph message, sort of. Yeah, so just now you see me like doing like the baking manually. That's because I'm using the keying set in Blender. So right click here and add into the keying set, and now under the keying sets you can see somewhere here, this is the flip fluid inflow that's been added into the button keying set. So whenever I press I, it's gonna keyframe for us. This is the button, I think the button keying set. But usually I'm just type I. If I tap on the I button, it's gonna keyframe the animations. Okay, so you can actually, instead of using random, you can use noise. And if you use noise, the fluids, it's gonna look like it's gonna display some kind of pattern. We can randomize the seed using float math. So this is just randomizing the seed, and then with the icosphere selected, we can keyframe. We can delete all the animations first, and then just do the manual baking. So we have to do this because the flip fluid does not respect the toggle unless we keyframe the animations. Okay, reset the fluid simulations and rebake. So see here, when the fluid is 0, it stops emitting for a split second, and then it starts emitting again. Probably it's clearer if we adjust this. So at this point, everything is emitting, and here this guy is gonna stop emitting, and then it's emitting again. These two will stop emitting. So that's the pattern basically, and it's gonna continue forever. Yeah, this manual part is kind of silly. I should have there is a way to do this using animation nodes. You can actually automate this, or using Python. So just do the bake the animations from SVerchok, and then bake the fluid system, and everything is gonna work. So it's a little bit like if you have a better way, like a more ideal way to control the system, is to use like a MIDI controller. And if you can do this in real time, it will be perfect, but this fluid system doesn't work like that. If you go back to the older Blender fluid, the fluid system actually works in real time. That's the older Blender fluid, not the new one, not the Manta flow. But flip fluid is faster in this case, so that's why I'm using flip fluid. And this is the visualization. Okay, so hopefully that's kind of explaining. It's pretty simple system, but you can modify this and make this a little bit better. So despite of the manual baking, the whole system is working fine. So the way I added the driver controller, I haven't shown you that. So this enable on and off, I just right click and copy the full data path so that I can simply paste it here. You see BPY data objects icosphere dot flip fluid inflow. Just get rid of the first bit and then replace it with the object. And then by doing that, you can control the value over here. So no matter if you are using like a random numbers, or you are actually using like a noise, vector noise, or like a noise displacement, whatever value you pass in here will control the emissions of the fluid. Okay, so maybe in the future this will be easier to do using geometry nodes. However, geometry nodes doesn't really control attribute value like this. So you can kind of trick it. You can use maybe like empty, or even better if you use armature bone. So if you control armature bone, you can control the drivers, and the bones actually can control toggle like this. I'm using SVerchok because SVerchok can actually drive this in real time. So if we continue, see, this is what happened. If I continue the bake, I'm resuming the bake. Now the controller stopped working, right? You can see, however, here SVerchok is still controlling it on and off. Just flip fluid doesn't really respect that update unless we update it this way again, showing it to maybe up to 240, 50, so 250, and then I just resume baking from 200, and then yeah, just do the bake. Now our system is working again. Okay, all right, so that's pretty much it. Hopefully you find this useful. I should have explained it better, but yeah, basically a toggle that's turning things on and off based on this pattern that's being generated using SVerchok nodes. All right, so thanks again for tuning in, and I'll see you next time. Thank you. Bye.